So from your text reading the other day, you hopefully noticed this idea, and maybe you didn't, that if we have some magnetic field and we send a charge through it, that charge experiences a force. And you had a couple of questions kind of pertaining to that in your assignment, but basically the force that a magnetic field exerts on a charge is related to the strength of the magnetic field, which is a capital B, the velocity of the charge, and the charge itself, the magnitude of the charge. So we can use these four different quantities to make an equation that can let us solve for the magnitude of the electric field, because we've talked about force, we talked about velocity, we talked about charge before, but we haven't previously talked about electric field magnitude. So the equation looks like this. The magnitude of the electric field equals the force, or excuse me, magnitude of the magnetic field, the force due to the magnetic field divided by the velocity of the charge times the magnitude of the charge, or the amount of the charge. Now remember that force is measured in newtons, velocity is measured in meters per second, and charge is measured in coulombs. So if we rearrange this, we'll end up with Newton seconds per meter coulomb, which isn't a very useful or like intuitive sort of unit. So what this actually is a Tesla, a capital T for Tesla. And if you don't know about who Tesla was, you should, because he was awesome. He was this crazy European inventor. He was sort of a rival of Thomas Edison, and he like made ray guns and stuff. Man, he was really cool. I should find like a documentary for us to watch about him, because he was neat. But anyway, we've named the unit for the magnetic field after Tesla. That's just how cool he was. So, but here's our formula, and this is, most of you haven't even listened to what I've been saying because you just want to get the formula and rearrange it and work the problems so that you can be as hedonistic as possible and waste as much time as you can. Or some of you will be watching this like the day of our quiz and hoping for the best. But anyway, here you go. Here's your formula. For any three of these givens, you can find the fourth. You know, that's not so bad. Alright, so if we have a charge moving through a magnetic field and it experiences a force, we just talked about that, it stands to reason that a current moving through a magnetic field, through the wire or some such, would also experience a force. And that's the case. The magnetic force that a wire carrying a current experiences is determined by the magnetic field strength in Teslas. It's determined by the length of the wire, I should put units in meters, and by the current in not the coulombs, excuse me, that is wrong, in amperes. Alright, and that formula is the magnetic force equals the magnetic field times the current times the length of the current carrying wire. What that was. That was weird is what that was. But anyway, here's your formula for the second part. So this stuff is pretty easy again. Use any extra time you have this period to finish up the bookwork that I gave you last time.